Hello, my name is Sean Montatsky. This is my makeup lab for Lab 8 op amps. Here is my name and student ID as required. And this is my proof of approval given by Dr. Mitchell. All right, this is my comparator circuit as shows for the first part of the rubric for the op amp. Those wirings are a bit finicky, but as you can see, as I rotate the potentiometer to the left, the LED is in full brightness, and as it backs off, it kind of dials down a bit. Again, wiring is a bit finicky, so it's not completely to zero, and it's kind of blinking a little bit. However, once I go back up, it is constant brightness. All right, this is my analysis of the non-inverting op amp. As you can see, V1 equals Vin, and using the junction rule, you go from ground, from Vin into R1, that creates the current on the left side, going out through the second resistor into V out, and that creates this relationship right here after algebra, which says V out over Vin equals 1 plus R2 over R1. Now, this is a quick little breakdown of the code that I'll be using. I'm just doing basic analog read for the different probes for the Vin, V minus, V out, and V plus. And for the processing, it is quite the same, or quite literally the same code used in Lab 8. This isn't a lab heavy, sorry, this is not a code heavy lab, but I just want to iterate that this is what I will be using in this video. All right, here is my circuit with its probes in its respective spots. Yellow going into V plus, white going into V in, green going into V minus, and blue going into V out. And once I twist the potentiometer, it is displayed in processing how it reacts. Once I go up, the V out and the V in track with each other, and then going back down, slowly the V out gets caught around 2 volts. It's a bit spastic, so I apologize for the noise and the fuss. But as soon as I go back up again, it catches and it tracks. Yeah. All right, my apologies if I didn't iterate what we were doing last time, but that was a unity gain. And now we are looking at the inverting amplifier. As you can see, I have a 2.5 going into V plus via a voltage divider circuit with 2 1K ohm resistors. I have the voltage being jumped by a 1K ohm resistor feeding into a 10K ohm resistor going into V out. Well, this is going into V minus, this is going to V plus, and thus creating a gain around -10. And that is displayed among the processing unit. As you can see, the V out is traveling 10 times slower due to the gain being around -10, which is, and to iterate, the gain itself is a ratio of R2 over R1, which that case is 10K over 1K ohms, which creates a gain of -10. All right, this is my analysis of the integrating op amp, and essentially what's going on is that you take the impedance of the capacitor and put it within the junction function, or, the junction rule, and your output of voltage into voltage out becomes -J omega times the capacitance and the resistance. All right, so this is my circuit made for the integrating op amp. I have the voltage in going into a 4.7K ohm resistor feeding into a capacitor with the -V grounded, and I have it available on processing. And essentially what's going on as I change the amplitude, what is going on with the integration is that it is shifting the phase. When we look at a sine wave of a cosine, where when we know that the derivative of a sine wave is a cosine wave, which is essentially a change of phase. And so as we go lower, we can see that there is a pretty prominent change of phase within the V in signal versus the V out signal, V in being green and V out being blue. That is essentially what is being represented by what's going on.